Okay, this is from the 2014 paper 2 from May. And we have IB biology field work, we have circumference of trees, and the distance from a riverbank. So the first question is state whether the distance is continuous or discrete. It's continuous because it's a measurable item. Now on your answer sheet you have to make sure you put the question numbers correctly. So 1, and they do have this at the top so you can kind of go by as a guide, you would do here. Just like they have. Now this is part A, so I would mark part A continuous. All they're going to grade is your answer sheet. So if you wrote on your paper, they're not grading this. They give these back to me. B says on graph paper, draw the scatter diagram. Now I'm just going to write B as graph paper, but you don't really have to. They already said they want it on graph paper. It says use a scale of 1 centimeter to represent 5 meters on the x-axis, and each centimeter is 10 on the y. So where are we counting? Each centimeter. Which one? How big is a centimeter? 1 block. So this would be 5, 10, 15. Do you see what blocks we're talking about where the kind of bolded lines? 20. How far do I need to go on the x-axis? 50 would be good because we got to get all the way to 47. Now, not only do you want to make sure you number them right, but there are points for labeling them correctly too. So I would put this is the x-axis, right? Now you don't have to start on the edge of your paper. You could actually start anywhere in there. And this is what? What is that x-axis representing? Distance in meters. And then I do my y-axis, and I always do mine on the edge, but it's probably better to do it like 1 row in. I'm thinking now, since they're scanning them now. Oh, I forgot something. I probably should have put my problem number at the top since there's a spot for question number. How far do I need to go on the y-axis? Oh yeah, all the way up to, well, yeah, 80, 90. And this is the y-axis. So I would turn it to the side and write, this is the y-axis and this is the circumference. And it's measured in centimeters. And this was problem number 1, so I need to make sure I put 1. And notice there's a blank out to the side. What should I put in the blank? B, since it's subsection B. So we draw a scatter plot. When x is 5, the circumference is 82. So let's see. If this is 10 all the way up, what's each line? 2. So 582 would be here. 12, 17. So, okay, so 10, 12, 14, 16, 17. No, 76. What am I looking at? Okay, so I made a mistake. I marked it out. They know I made a mistake there. 12, 76. What was I thinking? 70, 72, 74, 76. That makes more sense. Oh, that's what I did. 17 is going to... 17 would be here. 21, 68. 24 is 67. 30 goes to 60. 34 goes to 62. 44 goes to 50, and 47, goes to 50 as well. So if you're looking at the key as you go, this one's worth 4 marks for the graph. 1 point is the labeled axes and correct scales. Making sure you mark the way they asked you and labeling them is 1 point. You get 1 point for at least 3 correct points. 2 points for at least 6 correct. Or you can get 3 points for all 9 being correct. Now part C says to write down, I need my paper again, the mean distance, the x values, mean x, and the mean circumference, which is the mean of y's. So I know that's going to be part C, and I'm going to have to do I and I. Now, since we're putting in data, that's a stat type thing, and I need to clear out what I have. So you can go up to your L1 and hit clear, and let's type in the x values. And then your y values. Now, to find the averages, if we were just finding the average of one list of numbers, we would do one variable statistics. But we want to find the average of the x's and the y's. Which one will I choose? 2 variable statistics. Now it asks me, are my x's in L1? Yes. My y's in L2. Do I have a frequency list? So I need to make sure I clear that out. That's one of the things you'll need to remember to do. And then we're going to go down to calculate. Ooh, it gives me x bar. X bar is the first one. Now, they don't require that you put, sorry, it's yelling at me about attendance again. Hold on. Okay. Now they don't require that you put the units, but I probably would. Distance was, the x's were in meters. I don't want to ever lose a point for the units. I want to gain as many points as I can. So y bar is 65 centimeters.
Wait, what y bar is?
Y bar is 65. Okay. So those were worth 1 point each because you're just copying from the calculator. If we did this correctly, we're already up to 7 points on paper 2. Yay. Since y'all hate paper 2s. The next one is plot and label M, which is x bar comma y bar on your graph. Okay, so that x value with that y value. 26, 65. 26, 62, 64, 65, and it said to label it the letter M. That's worth 2 points. Now that was on the graph, so you don't have to do this part, but I do. Graph, paper. E, are more write-downs. It says write down the Pearson's product moment correlation coefficient R and the equation of the regression line, which is going to be a y equals. How do I find the regression line and the R value? Huh? It is in the calculator. Now, it doesn't show me that in this table. It's not in the two variable stats. Oh, stat linear regression. Up, it makes sure my x's are in L1, y's are in L2. Oh, look at that. R, notice it's negative, and then if I go 3 significant figures, 0.988. And then R, they give you your A, which it says is front of the X, and B, which is the plus B, so that's going to be at the end. What's the number in front of the X called? Slope. And the number in front of the Y? And the one at the end? Y-intercept. So I'm going to go 3 significant figures because that's the minimum. 0.756x plus 84.66 would be 0.7. If you look on the key, you could have written the whole number from the calculator. They don't count off for that. But you want to at least have this part. That's 4 more points. Draw the regression line on your graph. Okay, so 84.7, isn't that something important on a graph? What was that? You already told me. Y-intercept. So that's about 85, right? 84.7. My y-intercept is going to go through here. Your line of best fit also has to go through that M. So I need to connect that y-intercept with that M value. And you'll get rulers on your test. And you want to make sure the y-intercept and that M are connected. Now you would get 1 point for making sure you put the y-intercept, and 1 point for going through the mean point. So you could still get 1 point even if you messed up on that one. So F was also on the graph paper. G, use this equation to estimate the circumference of a tree that is 40 meters from the riverbank. Where's the 40 going to go in at? 40 meters from the riverbank. Now see, it's 2 points, so I need to have a method point and then an answer. 40 meters from the riverbank. It's the X. We're trying to find the circumference when the tree is 40 meters. That's the distance. So Y equals negative 0.756 times 40 plus 84.7. There's my method point. On a paper 2, you're collecting as many points as you can get. This is the one you definitely want to show your work on. And then we do whatever to get that in the calculator. Negative 0.756 times 40 plus 84.7. That's 54.46. So that would be 54.5 centimeters. Whoops.
Wait, can I see the graph one more time?
Mm-hmm.
Thank you.
You're welcome. You okay with that so far? All right. You can say something else.
For the graph, like the line of X fit, do we need to like draw an arrow to make it a line?
They won't count off if you do or don't. So. Good question, though. They're not nitpicky on that part. What did y'all say next? Number 3? Okay. I mean, if we have time, we can go back and get some of the other ones, but I just want to make sure we do the ones that you have. Now, on your paper, since we already went into the next section, you could either start number 3 right here, or I'd probably go to the back page. Now, 3 would be like that.
So do you have to do it like that?
You specifically have to look like these.
Okay.
The reason is they are scanning in these, and the computer has to be able to recognize which problem number it is.
I see this.
Well, it's ugly, but it's there. Now, sometimes on my papers, when I'm working these out myself, I tend to maybe write down the information I'm given, just so I don't have to keep looking back at the booklet, but you don't have to. So we have a sequence. What's happening in this sequence? So that's when I would maybe write down, so U sub 1 is 600. The next term is 617. The next term is 634. And the next term is 651. What's happening each time? But how's it getting bigger?
It's 17.
How is 17 changing it? Okay, we're adding 17 each time. So I saw that sequences. And remember, I don't remember a lot. So I'm going to go back through my book and look for sequences. In my formula chart book, I found 2 formulas that say sequences. One is arithmetic and one is geometric. Do you remember which one would be adding each time? Which one? Arithmetic. So on part A, we're trying to find the 20th term. So if I were doing this on part A, they don't require that you do it, but I'd copy down my formula. U sub 1 plus n minus 1 times d. So we're trying to find the 20th term. U sub 1 would be the first term. 20th term minus 1, so you could write this as 19, times d, which is what we're adding each time, 17. You get a point for picking the correct formula and correctly substituting in the 600, getting 19 there and 17 there. Now it also says they would give you points if you actually wrote out to the 20th term. Is there a method to find the 20th term? It is a correct method. It's not the most efficient time-wise. What is the 20th term? 923?
Yes.
Find the sum of the first 10 terms. All right. There's 2 different formulas for sum. And it doesn't matter which one we pick. Let's see if what's the first one need? N, number of terms. U sub 1, first term. N, number of terms, and D. Could we use the first one?
Yeah.
We could. Let's not. Okay. Okay, so for part B, we're trying to find the sum of the first 10 terms. The formula I like is that we're going to take the number of terms divided by 2, u sub 1 plus u sub n. So I need the first term, and then I need the, what would u sub n be? 10th term. So we need to find the 10th term. So 600 plus 10 minus 1 times 17. Can somebody find the 10th term for me?
Yeah.
Okay. So I used the same formula I used in part A, but plugged in 10 instead of 20 to find the 10th term.
Wait, why don't we have use the 20? I mean, use the 10?
Because the formula says if we're finding the sum of the first 10 terms,
Oh, you can divide it by 2. Okay.
we have to plug in 10 for our n. So this is the 10th term, not the 20th term like we had in the first one. Now, could you have listed out the first 10 terms and added them up?
Definitely.
You definitely could have done that. They wouldn't count off. They would not count off for that. It's a little bit more work than you need, but now one thing you might want to do, they don't ask you to, you're not required, but maybe box answers on this one. What is the sum of the first 10 terms? 6765? And since that's exact, I would just leave it exact. Okay. Now consider the next sequence. The next sequence is v sub 1 is 3, v sub 2 is 6, v sub 3 is 12. What's the pattern on this one? Times 2. So you can even write times 2. Okay, so find the exact value of v sub 10. So if it's times 2, it's not the same formula, right? Which one are we going to use now? Geometric. It says to find any term, I take u sub 1 times r to the n minus 1. So n is the term position that we're looking for. Oh, we're using v, so I'll just change that to a v, that's okay. V sub 10 equals, what would be the first term? 3. What's r? The rate, so that would be 2 n minus 1. 9. 3 times 2 to the 9th. I believe it's 1536. Find the sum of the first 8 terms. Could you technically multiply by 2 each time and find the first 8 terms and add them up? You could if you wanted, or I can use the formula. The formula for sum says to find the sum of the number of terms, it has u sub 1 r to the n minus 1 over r minus 1. So if I'm finding the first 8 terms, I have to start with the first term. You said r was 2. 2 to what power if I'm finding the sum of the first 8 terms? 8 minus 1 divided by r minus 1. Be careful putting that in your calculator. You might want to do the alpha F1. $765? Okay. Just so you know, if you're when we're looking at this mark scheme, I want to make sure I show something. 765 was the answer. This part was worth a total of 3 points. This G2 out to the side. That means if somebody just wrote down the right answer, obviously they did all their work in their graphing calculator, you'd only get 2 points. By showing that formula, that's how you get the full 3 points. Does that make sense? You can get partial credit by just writing answers, but I don't want to show everything and get the most points. Now, if I were taking this test and I looked at part E, would that kind of scare you? Do you have to do part E?
No.
You don't have to. You can kind of stop where you're at. So it asks, when is V bigger than U? The smallest value for which it's bigger than U. Well, let's see. Didn't we know V sub 10 and U sub 10? So I would maybe compare those. I've got V sub 10 is 1536, and U sub 10 was 753. Oops. I would mark that out and write it again. Do you think that's the first time that it's bigger?
No.
We could find out. Could we go backwards and find out V sub 9 and U sub 9? And V sub 8 and U sub 8? And so I could work backwards. On V, we were multiplying by 2 each time, so to work backwards I would divide by 2, so this would give me 768. 384, 192. Yeah? Am I doing that right? Okay. On the next pattern we were adding 17 each time, so if I wanted to work backwards, I would subtract 17. Oh, Lord. I could do the other ones in my head. 753 minus 17 minus 17 minus 17. And now let's check to see if we've gone far enough. When does pattern V pass up pattern U? It's still below it, isn't it? So it's at 9. So K equals 9. Now you could have done it where you set the equations up and tried to solve it. I wouldn't have done that.
Well, I'm really confused on how we got 9.
The 9th term is when V is first bigger than U.
Oh, okay.
At term 8, it was smaller.
Okay.
And they want to know when was the first time it's greater. Which term? For that problem, you could have gotten 12 points for everything else. They usually put in that last part, kind of the difference between the 6 and 7s.
So they don't have to get that much.
No, it was supposed to be the term position. And term positions are always whole numbers. Okay, y'all said 4 and 5? How are we on time?
1, 2, 5.
How are we on time? Okay. Do you want to do 5 and come back to 4? Maybe we, or what? How do we want to do this?
Yeah, let's just do 5.
And then we'll come back to number 4. Okay. So number 5, I would start on a new sheet.
4 is easy.
4 is easy.
Okay, maybe that's easy, but
It's just formulas. We'll go back to it if we have time. 5, I know we're going to forget. 5 says normally distributed. On my paper, I would go normal distribution. Okay. I think that was that bell curve thing. And there was a whole thing in the calculator about it. So I want to review this with you. It says the mean is 60 and standard deviation is 12. Show a diagram of this information. I'm going to see which points they give you for each part. The diagram looks kind of like the bell curve. $60 would be in the middle. It goes up, and it goes down. Whoops. Standard deviation, what's that, 60? I can't write. 60, 12 this way would be 72, 84. Remember doing this? No, so 12 backwards would be 48, 36, 24. Each mark is one standard deviation away. Part A. Write down the probability that a randomly chosen candidate scored at most 60 marks. 60 or below. What's the probability I'm going to find somebody who scored a 60 or below if the mean was a 60? 50%. That's a one-pointer because you shouldn't have to do any work. They would accept 50% or 0.5 or 1/2. They'll accept any way you write 50%. They're happy. C says that He-Jin scored 80 marks. Find the probability that a candidate scored more than He-Jin. Okay, so more than 80. That's not on my graph, is it? Let's review how to put this in the calculator. This is normal distribution. So this side stuff I wouldn't actually write on my paper. We're doing it for this. Distribution is under DISTR. So I would go DISTR. Do you see where that button is? It's above bars. Gotta turn it on first. And I just had a brain fart. Hold on. Alright, it's normal CDF. Gosh. Okay, so I'm making a note here just so we can remember. Because I don't. Lower boundary. If we're wanting more than 80. What's the lower boundary?
80.
Yep. If we want more than 80, it's 80. The upper bound is the biggest number you can think of.
Infinity.
Which is 1 times 10 to the 99th. That's 1 with 99 zeros behind it. That's pretty big. Ooh, that weird U-ish shape. That's the mean. Circle hat. 12. And it fills in a formula for you, and it says 0.0477. Now, you could write all of them, or 3 significant figures. 1, 2, 3, so 0.0478. Done. D. Candidates' marks in the physics exam. Oh, there's a different exam. This other exam has a mean of 63 and a standard deviation of 10. Now that we remember the symbols, I'm going to use them in this part. Mean of 63, standard deviation of 10. Jen also scored 80 marks on the physics exam. Find the probability that someone scored less than Jen. So less than 80. So we're going to go back to normal CDF. What's the lower bound this time? Negative infinity, right? Upper boundary is 80 this time. The mean is different. The standard deviation is different. 0.95543, blah, blah, blah. You could write the whole thing out, or 0.955. Ooh. So 96% of the people scored less than an 80? Ooh! Okay, so determine, is this mark better in physics than in chemistry? Which one's better? The top one's better?
I mean, okay,
Why?
so no one, almost no one
Oh, wait, oh, she
scored
did
more
better?
than an
Oh,
80.
yeah, she did better than physics.
How do you know?
Because it's
Because
less than the
like
difference.
90 people,
Well, the difference between, like,
I mean, they're pretty
I don't really know.
Okay, so more than 80 was 0.0478, right? So how many people scored less than 80, or what percentage on this one? So 1 minus 0.0478. 95.9522 scored less on the chemistry test.
She did.
And 0.955 scored less on the physics test.
so better on physics.
And they want to know a reason.
Because I said so.
Physics results were better. And you could use anything, any kind of comparisons. So if I said 0.955 is greater than 0.9522. Some kind of comparison. Notice that the other one's well calculator based. Now this is a reasoning one. F would be the hardest one. Find the minimum possible mark to obtain an A. If we're trying to find the value when we're given a percentage, so 10% would be above, right? And 90% would be a below, right? This one is inverse norm.
No problem, John.
Whoops. What's the area to the left of what we want? 90% would be 0.9. The mean is 63. So actually, if you got a 75.8 or higher on that test, they labeled you as an A.
Wow, that's
Top 10%. I'm sorry. Do we have time? Oh, we still have 25 minutes.
No, we don't. No.
You don't want to do 4? Okay, then y'all.
You can go over other spots. Yeah.
Okay, that's fine. Number 4. We're given a triangular field on the ground. Now, personally, I like to sketch it on my paper so I can make notes on it. We have this A, B is 70 meters. Big C is here, 50 meters, and 78 degrees. Cool. It says find angle ABC. So we want to find angle big B, right? Is this a right triangle? No. Okay, so what I would do, since this is big C, this is little c, big B, little b, big A, little a. This is geometry, but this is the crazy geometry. It's not a right triangle. We have to use sine rule or cosine rule. Do you remember which one you like better?
Sine rule.
Now, I'm trying to find, I know angle C, and I'm trying to find angle B, so I'm going to use the B fraction and the C fraction.
Good idea. I'm learning. John,
Little b is 50. I don't know big B. Little c is 70. And big C is 78. I need a cross multiply. I was writing it the other way, I'm sorry. Are you with me so far? I cross multiply.
Oh, I should probably take.
So I need to take 50 times the sine of 78. Then what are you going to do to it? Divide by 70. So sine of big B equals Make sure we're in the right mode.
What mode am I supposed to be?
Degree.
48.99.
50 times the sine of 78 divided by 70.
Yeah, I totally did.
I haven't gotten the angle yet. I'm just trying to get the... Are you in degrees?
We are now.
I am in Fahrenheit degrees.
50 times the sine of 78 divided by 70 gives me 0.6986. Is that the actual angle? That's what sine equals. So how do we find the angle? It is something with sine. The inverse sine of whatever that answer was.
Yeah,
44.3.
24.3.
Now, if geometry and the non-right ones is not your place, would you spend time on 4 at the beginning of the test?
No.
I would definitely do 1, 2, 3. So I would do any of them other than that one, if that's not my strong point. If the geometry is your stronger point, maybe you skip the sequences. Yeah.
I have a quick question.
Yeah.
Okay, so if we were looking at one, and we could do A and C, but not B, would they count off if we didn't do B?
You're only getting credit for the points you get.
Okay.
You're collecting points. Area. Area says, okay, the area formula says, area equals 1/2 a side times a side times the sine of the angle in between. Let's see. Oh no. I know this is 44.3. Do I know the two sides around it? No. What angle is between two adjacent sides? A. So I need to change this. We're going to do B, C, and the sine of angle A. Oh, but how do I find angle A? I only know B and C.
You add 44.3 together with 78.
Okay?
Minus 180.
Plus 78.
Or 180 minus that.
180 gives me, I got 57.
Go for it.
57.7? I'm trying to hurry so we can get through the problem. Sine of 57.7 degrees. These are so much fun to grade. I'm looking forward to it so much. Hey, if somebody messes up in part A, I have to keep redoing every problem with a different answer. So 1479.208, you could write the whole thing. Or you could go to, what would be a good stopping point? You could go all the way 1479.2. You could write it as 1480.
Whoa!
Because that's three significant figures.
Even if it's...
The minimum you need to go to is 1480. Because that's rounded to three significant figures.
Okay.
But you could go more. 1479.2 might be where I go. Oh, were there units?
So you do one?
Meters.
Yep. Meters squared for area. Do not lose the point for that. Alright, now let's see what's the next one. Find the length of B to M. Whoa.
Wow.
B to M? It does not necessarily make a right triangle.
Even if you have the midpoint?
The midpoint doesn't necessarily make it a right triangle. And it doesn't necessarily split that in half.
Well, not in my universe.
What are you talking about, Lily?
This one you'd actually have to use the cosine rule on. Let me redraw the picture. I know B to A. That's helpful to know. I know A to M, right? If it's midway, it's going to be 25 there. I'm trying to find that side.
But it's not a right triangle.
Not a right triangle. I'm going to call it X. We know A. To use the cosine rule, we have to know the angle across from the side we're looking for. Because it says, take for little a squared, it's going to be little b squared, plus little c squared, minus 2bc cosine of a. That angle, I'm writing it directly down from your formula chart. I didn't memorize that, it came right from here. Notice that that little a and the big A over there means that that angle has to be across from the side we're looking for, is it?
Yeah.
Okay, so we're looking for this little side, I'm going to call it X. Little b in this instance is going to be 25. We'll just call 70 the little c. 2 times 25 times 70 cosine of 57.7. Could you possibly have gotten the 7 points for the top and then gotten to this one and gone,
Like,
never mind? You could have. Collect as many points as you can. Don't get stuck spending a whole bunch of time on one you don't remember how to do. Move on. That's why, one of the reasons I do suggest doing one problem per one side. That way, if I started this and got down to B and went, oh, crap. Here's the next problem. You're timed. Work on all the ones you are sure of, then come back to these afterwards. Cosine 57.7. Now that gives me x squared, right?
correct.
So how would I find the actual length of B to M? Square root of the last answer. And remember, if you've already got this in your calculator, square root of, and you can grab it and press enter. So 60 point, I could write it all out, or at least go to 60.5 meters. Okay, now I'll just go ahead and tell you, if I was having trouble with this one, and I knew this little side was 25, and this side was 70, do you think this side is going to be smaller or bigger than 70?
Smaller.
Yeah, that side's pretty long comparatively. So this one's going to be smaller than 70, but bigger than 25. If you came up with something, I don't care what, like if you thought it was 55, you might miss this part, but maybe you could do part D with that wrong answer. Part D says that we have a vertical mobile phone mast. So TB is vertical to the ground. What does that mean if it's vertical? Upright. So T to B is vertical, so this is kind of a 3D view of it. This triangle right here is a right triangle. I love that. Woo! On part D, I would draw that. T. Oh, N is in the middle. B is here. I'm going to draw it where I can see what's going on a little bit better. Here's M. We just found B to M, right? 60.5. If you had messed up on there, could you guess something? And so you can keep doing this problem and get the points for this part. So even if your part C was incorrect, you could still get points for this one since it's a right triangle. Alright, so it says calculate the angle of elevation from N to M. Now it doesn't necessarily split that number in half, right? So there's a couple of ways we can do this. I think the easiest would be to find, well, how tall is T to B? So how tall is this whole side? I'll call it the height. How is that related to the angle we know? Opposite, and 60.5 is adjacent. Which one uses opposite and adjacent? Tan of 63.4 equals opposite over adjacent. So it's going to be 60.5 times tangent 63.4. Now that's the entire height. What we're trying to find, it says we want to find the angle of elevation from N to M. We're trying to find this little bitty angle right here. 60.5. So if I'm trying to find that little angle, I need to know N to B. Well, how far would that little piece be? Half of that. And that's 60 point... Oh, 60.4 something. This is definitely not drawn to scale because it's almost the same length as this one. So this is 60.4. How can I find the angle right here? Tangent of that angle equals opposite over adjacent. Now I want to find the angle that goes with that ratio. Wasn't it something like second tan? Or 45. On paper 2, I highly suggest looking through them and picking the ones you feel strongest about.